In this lab, we're going to talk about freefall. The objective of this lab is to measure the acceleration due to gravity of a freely falling object. Now, this was first discovered by this guy right here, Galileo. And hopefully, it always brings to mind a Queen song, Bohemian Rhapsody. If you haven't heard it before, you should probably listen to it after this video. Anyway, Galileo started measuring position. And the way he did this was he looked at a ramp. And then he rolled a ball down the ramp. And he kept doing this, and he thought, okay, well, what do I need to know about this? And he said that we'll start by looking at this object's velocity. And he defined this velocity as a change in position over a change in time. And he thought that was all well and good, but then he started looking at acceleration, which he described as a change in velocity over a change in time. And he looked at this, and this was all well and good. But Galileo thought, you know what's better than a ramp? Or what's the biggest ramp I could find? Well, he went to the Leaning Tower of Pisa. And as the legend have it, Galileo went all the way up and dropped stuff off for the biggest ramp he could find. And he found out that all of these things fell at about the same rate. And that's the goal. So to do this, we're going to wind up using this apparatus. So this right here is a giant electromagnet, and it's going to hold a bob. This powers the electromagnet. This powers the spark generator, which is why we have these wires here. So your frequency, your time between sparks, frequency equals 1 over time between the sparks is going to be given by this knob right here. Other things to note, this knob or button releases the electromagnet. This is a red button, and you've been waiting your entire physics lab career to push a red button. Well, this is the lab for you. So the first thing we are going to do, we're going to put a piece of tape over this wire and ensure that the tape is over the back wire. Put tape over wire. The way this works, this is spark tape. There's going to be a spark that's going to jump between those front two wires. And then we're going to hang this mass over the tape. So your electromagnet should do this. Now, one thing I want you to note about this is that if you take a very close look, you'll see that you only have about 1 millimeter of clearance right here and between here. So if this happens to hit, it will go pew and fly off and probably land on someone's foot. So please don't do that. Next, after you have done this, you can flip the spark generator on. Leave it off until someone goes here. And here's why. You will notice that if you push and hold the spark generator, you'll say, wait a minute, isn't that a high voltage shot going between those two wires? Yeah, the answer is yes. So please, please, please stay clear of the spark. That is important, and it merits some little important words. Stay clear of the spark. Wait till you're handed back, or till you're out of the way. Then, if we can hold the button down, push the release button, it will fall. And notice, only let go of the red button after it hits the ground. So what this does is it will leave a bunch of little marks on your tape, and I want you to circle the marks. Spark tape, as it gets knocked around, it's a wax coating, and that wax will go away, and it'll look like you've got a whole bunch of marks. So circle the marks you're going to use. That is an important note. Notice, in this case right here, you'll notice we've got two. So you're going to have to pick one. And this could be the spark misfired, could be something weird ran against it. But you have to make a judgment call. So let's look at how we record data. Again, we're always going to record our raw numbers. So our tape readings, in this case, were 2.0 meters. And these are really big numbers, so yours are going to be smaller. 2.00 meters and 5.00 meters. Then we look at the differences in these. So the difference between these is 1 meter. Difference between these is 2 meters. Then we care about what is our velocity right here. So change in y over change in time. So the change in this would be 1 meter. 1 meter divided by 1 over 30, which equals 30 meters per second. Your second one down here would be 2 meters over 30, so this equals 60 meters per second. Your change in velocities here, this is 30 meters per second. And this is just in meters per second because I'm making up numbers. And to get your acceleration, it is your change in velocity over change in time. In this case, it would be 900 meters per second. Your numbers are going to be a lot smaller, but this is in general how you walk through the calculation. Then you're going to have a value for g. Right here you'll have like a1, a2, a3. You'll have acceleration to all these points, and you can get some average value for a. That's one way. So you'll get an average, and you'll get a plus or minus here. You will also graph right here, and again, acceleration. Acceleration is the change in time, change in velocity over change in time. So you'll plot your velocities, plot time. You'll get acceleration here, so this would be plus or minus. So this is another way you can get error. Or a third way you can get error is look at the error here. Error in your first reading. See how close can you read a meter stick. And then propagate that through. So there are 3 ways. You can probably come up with more, and if you would, just please talk to us about this. So in conclusion, very important, stay away from the spark. Don't want anyone to get zapped. Circle all your points that you're going to use. Otherwise you risk knocking them over, creating some other random point that you don't want. You're going to calculate acceleration due to gravity. A couple different ways to do this. And always, always, always remember to read to the 10th of a millimeter. So I hope that makes sense. Please go through, read your lab handout while watching this video, and ask any questions you have in lab. Thanks.